here is a boost converter that brought me to Caltech, but that converter only provides positive polarity. How can I make a boost converter from positive input? And that's a problem for this technology, that each power processing stage up to that time was positive input, positive output. You couldn't have a polarity changing input voltage to generate same output voltage. You see what I'm saying? Plus minus input to get a plus on the output. So what we did is, what I said is, okay, how about if I have, and you can see here, I started with the original two converter with this inductor. And I did something which is kind of a, let's say, no-no. You put a switch in series with inductor. Now, in the actual circuit theory, you can't put a switch in series with inductor. If the switch turns off, the energy in inductor, from Faraday's day, if you turn off, you have a big spark. And in fact, Henry proved that, he invented his inductance by, they wanted to create a spark by turning off the current. And what he did, put many terms on it to increase inductance. Suddenly, turning off the current was a huge spark. And of course, turning on the current is no problem because current starts at 0. So it's turning off. But this is not the active switch. This is a diode. And the diode says, I will never turn off until this inductor current goes to 0. And my circuit works that way, that I resonate in this way, and when inductor current goes to 0, then it turns off naturally. All right, so now, how do we get 3 switches? Funny thing. Look at this part here. Doesn't this remind you, just like that boost converter, except position of diode, the capacitors are interchanged, right? So, and then this part here acts like a translation stage. This is like a resonant inductor, and this capacitor transfers its DC charge to DC charge here. So what's here resonating only ripple on a capacitor. And that's why this resonant inductor is very small. Okay? So basically, that permits that you get this converter operated in the same way as a regular boost converter, but provides negative output voltage polarity. Well, that makes another idea. If this positive input gets a negative output, now couldn't I just reverse direction of these two and provide a positive output? Yes. But if I can from positive get a positive or negative, I can surely get from positive get positive output and negative get also positive output. So what is that? I can have bipolar input voltage and get the output voltage of that polarity. So what is happening now is we have, for the first time, what we call through bridges PFC converter. AC line comes directly. And even though there is no bridge rectifier for diodes, still we generate output voltage sinusoidal, and we generate a current directly in phase with the voltage, with a low total harmonic distortion by forcing this current to be proportional to this voltage. Okay? So I'll go quickly because you don't have time. This is implementation of that 4 switch. And then here is actually what you have. You have this inductor current on input, have an average doing like this. But then you put high frequency filter, and you get really a simple sine wave current. And here are these actually measurements of sine wave voltage and sine wave current. And I have efficiency. Now the important thing is efficiency as you go to 100 volts doesn't drop to 92 or 3% because you don't have a diode drops. So it operates without diodes over the whole range. Demo. So here is a demo I prepared here. I don't know if you have time, but basically you have AC line, and that's what we're talking about, power factor. I want to mention that, so maybe part of my time that I'm going to use for afternoon discussion is going to be burned here. So the point is AC line is, you see, it's a not sinusoidal voltage. I showed previously sinusoidal voltage creates sinusoidal current. But the current in blue is directly proportional to the voltage. And why is this voltage distorted? Because in my building, like in any other building, everybody is rectifying AC line with that simple diode bridge and taking the power at the peak of the voltage and loading it and making it a bad power factor. And not only that, making bad harmonic distortion, which goes to every other user and contaminates their AC line and so on. So that's really the importance of that power factor. Yes, yeah, I'm going. So the other advantage is, how do you build isolation? Now you split this capacitor into 2, and you have isolated version. So now this operates at 100 kilohertz. And the whole thing is small, and you have isolation, etc. So now it's an AC transformer. You can scale it up to high power. And you're comparing 3 versus 14 switches. And the efficiency of this 3 stage is typically 90, 91%. The efficiency of the left-hand side is 97.5, close to 98%. So you have a tremendous efficiency advantage. The other thing is it naturally builds into three-phase. Here is currently how we do three-phase. We rectify it to 400 volts line, and then we get another DC to DC converter to step it down and provide isolation. But new single-stage three-phase rectifier takes truly Tesla's three-phase concept and doesn't prematurely rectifies to 400 volts DC, but operates on basically this flux density Tesla unit. We have three converters, and each one operating from this, but 120-degree phase shifted, and all three combined together in basically the DC current. So therefore, each one supplies what's needed, just like a three-phase system, with no energy storage in the system needed. And each phase has this simple three-switch converter. And this is basically what it shows, DC current. And now another point I want to show you, and we can, it's down in the illustration. What can we do? This is AC to DC. 3 stages can be done in a single stage with a high efficiency. What can we do with the DC to DC? Normally, DC to DC converters have a big storage inductor, and big size and efficiency goes down. Well, I'll show you here. This is 200-watt converter, which basically has a very small size magnetics, and it doesn't operate on megahertz to get small size. It operates at 50 kilohertz for 48 volt to 24 volt output, no heat sink needed, and this is the size of it. And the magnetics here is very little core with a 30 millimeter square. You know, the normal PWM converters will need a 40 times bigger core. So this is something for a very high power density converter. I'll show you. You can go around so you can see it. This is yes. Yeah, I think for a demo we can. There will be a break after this. If you're welcome, I'll.
Break is only 6 minutes. Thank you.
All right.